We have some new data from a potentially supervolcanic eruption in Italy. Let's talk about what this means and why it matters. It can be hard to keep up with all the news about volcanoes and what might happen if there's an eruption. There are volcanoes which erupt frequently, and ones that haven't erupted in thousands of years. Sometimes they put on quite the show, and sometimes it can be almost impossible to tell that they're even active. There are lots of different ways that eruptions can go, and scientists spend their careers trying to figure out which way a volcano might go before and during an eruption. And when a volcano does erupt, scientists work quickly to understand what happened and how to better forecast other volcanoes. In this episode, we will be discussing Campi Flegrei, a volcano near Naples, Italy. This volcano is interesting because it has a very high likelihood of erupting in our lifetimes. If it were to erupt, it would cause significant damage in the densely populated region surrounding the volcano, and it could affect the rest of Europe too. We already know a lot about Campi Flegrei, but new research helps us to understand how it might behave in future eruptions. One of the reasons that we study Campi Flegrei is because its future eruptions could be large enough to be classified as supervolcanic. A supervolcanic eruption is defined as any eruption with a volcanic explosivity index of 8. The VEI is a scale that scientists use to estimate the relative violence of volcanic eruptions based on different characteristics of the eruption. Eruptions with a VEI of 4 or below are considered small. Eruptions with a VEI between 5 and 6 are considered moderate, and those with a VEI of 7 or higher are considered large. An eruption of a VEI of 8 or higher is considered to be a supervolcanic eruption. These are the rarest type of volcanic eruptions. To put these definitions into perspective, small eruptions might only send lava a few hundred meters from the vent, whereas large eruptions can eject more than 10 billion cubic meters of material. A supervolcanic eruption can eject more than 1,000 billion cubic meters of material. The largest known supervolcanic eruption in Earth's history is the Toba eruption in Indonesia. It had a VEI of 8, and it occurred approximately 74,000 years ago. The Toba eruption ejected over 2,800 cubic kilometers of ash and pumice, and it left behind a caldera that is now Lake Toba. The eruption caused massive climate disruption worldwide and left behind a layer of ash that is over a meter thick. You can find this layer of ash in the Greenland ice core. While the Toba eruption was huge and obviously impacted the world, it's also thought that several other supervolcanic eruptions have occurred throughout Earth's history. Evidence of other supervolcanic eruptions can be difficult to come by because so much time passes between them. But scientists have been able to identify locations where supervolcanic eruptions have occurred in the past by looking for calderas. A caldera is a large bowl-shaped depression that forms after a volcanic eruption. Large eruptions can empty magma chambers very quickly. When the pressure is suddenly released, the roof of the magma chamber can collapse, forming a caldera. Scientists can look at the size and shape of a caldera to determine whether or not it was formed by a large or supervolcanic eruption. Campi Flegrei is one of the most heavily populated volcanic regions on Earth. This makes it especially important to understand the hazards associated with the volcano and its potential impacts on the surrounding areas. There are several faults in the region, but the main fault is called the Naples Fault. The Naples Fault is actually a series of smaller faults that run along the northern edge of the caldera and through the city of Naples. The faults are capable of producing earthquakes with magnitudes ranging from 5.5 to 6.2. Earthquakes of these magnitudes could cause significant damage to the surrounding area. There are three main concerns with Campi Flegrei. Those are the potential for earthquakes, the potential for pyroclastic flows, and the potential for ashfall. Pyroclastic flows are fast-moving currents of hot gas and rock that can reach speeds of over 100 kilometers per hour. They can travel long distances in a short amount of time. Ashfall can also travel long distances and can disrupt air travel, damage buildings and other structures, and contaminate water sources. Let's discuss what new data has taught us about Campi Flegrei and what it might mean for future eruptions. In the past, Researchers have estimated that the magma chamber under Campi Flegrei is about 30 kilometers wide. However, new research suggests that it's actually closer to 50 kilometers wide. This means that the magma chamber is much larger than previously thought. It also means that there is a lot more magma available to produce future eruptions. The new research used seismic data from over 300 small earthquakes that occurred in the Campi Flegrei caldera between 2012 and 2020. The team located the hypocenters of the earthquakes and used that information to create a map of the magma chamber. The magma chamber is located about 6 to 8 kilometers beneath the surface. It's also about 2 to 3 kilometers deep. The researchers also found that the magma chamber is not uniform. There are areas of higher and lower seismicity, which indicates that the magma is not evenly distributed. The higher seismicity could be due to areas where the magma is more concentrated. While this new data does not directly tell us anything about what future eruptions might be like, it does provide some clues. For example, the size of the magma chamber may help researchers to better predict the size of future eruptions. If the magma chamber is larger than previously thought, then future eruptions could be larger as well. Additionally, the fact that the magma is not evenly distributed within the chamber could also help researchers to better predict where future eruptions may occur. Another piece of good news is that it seems that there isn't likely going to be an eruption in the next 300 years. Researchers looked at the rate of magma supply to the magma chamber and estimated that it would take at least 300 years for the magma chamber to fill up again. This means that there is no immediate danger of a large eruption. However, it's important to note that this is just an estimate, and the actual time frame could be longer or shorter. Volcanoes are fascinating and terrifying. It can be helpful to learn as much as possible about them so that we can better prepare for future eruptions. New research teaches us that the magma chamber under Campi Flegrei is larger than previously thought. It also appears that there is no immediate danger of a supervolcanic eruption. However, it's important to continue to monitor the volcano closely in order to better understand its behavior. If you enjoyed this episode, check out this playlist for more. Let me know your thoughts in the comments below. Thank you to all my supporters for making these videos possible. Your support really does make a difference. If you'd like to support my work, check out my support page. Don't forget to follow me on social media, and thanks for watching. Imagine being able to travel back in time and witness some of the most spectacular natural phenomena in history. You could see the eruption of Mount Vesuvius and Pompeii, or the great eruption of Krakatoa. Wouldn't that be amazing? Well, it's actually possible thanks to a new project that uses machine learning to reconstruct past events from satellite images.